Okay, the triangle inequality. It states that for any triangle, the sum of the lengths of any two sides is going to be bigger than the length of the third side. So, say you have this triangle. If you take the length of A and add it to the length of B, you will find that it's always going to be longer than the length of C. Also, if you did it differently, if you took the length of A and then added that to the length of C, that's always going to be longer than the length of just B. Similarly, if you take B, add it to C, it's going to be longer than just A on its own. Another thing, look at B. Now B on its own looks like it could be longer than C. It could be longer than C, right? And also, B on its own is definitely longer than A, right? So B could be longer than C, and it's definitely longer than A. But no matter how long B is, if it's one side of a triangle, it's never going to be longer than A plus C. So even though it's longer than A, it's not going to be longer than A plus C combined. And that's the idea. No single side of a triangle is ever going to be longer than the other two put together. That's what the triangle inequality says. It says that two sides together will always be bigger than the third side by itself. So we can use this knowledge to check possible triangles, right? So here, it says, can three side lengths of 25, 15, and 5 form a triangle? Well, we need to check, because we have to check to see if every combination of any two sides is greater than the third side. So we have to check every single combination. So we have to check A and B, B and C, and A and C, and see if each of those combinations is bigger than the side that was left out. So this is what they're doing here. So we have our three sides, 25, 15, and 5. And we're going to check scenario A. We're going to add the first two sides and see if that's greater than the third side. So the first two sides are 25 and 15. Is that greater than 5? 25 plus 15 is 40. And then 40 is bigger than 5, so this is true. We're going to check a second scenario. So now we're going to check 25 and 5. Add those together and see if it's bigger than 15. So 25 plus 5 is 30. 30 is bigger than 15, so that one checks out. Now we have to check the last scenario. We're going to check if 15 plus 5 turns out to be bigger than 25. So here we have 15 plus 5. 15 plus 5 is 20, and 20 is not bigger than 25. What this means is that even though two of the scenarios is true, the third one is not true. And they all would have to be true for these three lengths to be able to form a triangle. So the type of triangle that you end up forming is something that looks like this. And it turns out that 5 centimeters and 15 centimeters fall short of what is needed for a real triangle to work out. Here's what the real triangle needs. So we need something more on this side and something more on this side. Right? So the inability to get a true statement out of all the different combinations of two sides versus the third side makes it that this triangle is not a viable triangle. It's not a triangle that can really exist. Here's another example. Two sides of a triangle measure 8 feet and 10 feet. What is the range of lengths of the third side? When they're asking you for the range of lengths, that means something that has an inequality in it. So it tells you that it could be starting from one number, maybe 3, and go up to perhaps 10. So the range is between 3 and 10. So the unknown length of the third side could be between, say, 3 or 10. That's what they're asking. What's the range of lengths, right? So it says, start by writing 3 statements. I think probably it would be better to start with drawing a triangle. So draw a triangle. Alright? And then we can fill in what we know. We know that one is 8 feet in length. The other one is 10. And I'm not drawing this to scale because these all look very close to each other. So one side's 8, one side's 10. We could call this side x, which is what they've done. Use x for the unknown side length, right? So that's what we've done now. So what they're asking us is what's the range of lengths that x could be? X could be no smaller than which number, but no greater than which number for this triangle to work. Okay? So after drawing the triangle now, we can take a look at writing the 3 statements that we know. So we just learned that add any of the 2 sides of the triangle, and you know that whatever you get has to be bigger than the third side, right? So first, we know that 8 plus 10 has to be bigger than x, right? So if we add the side that measures 8 to the side that measures 10, we know that whatever we get from that sum should be bigger than x. That's what this statement is saying. So here we have that statement. The second statement, statement B, is doing a similar thing. But it's just picking 2 different sides of the triangle. Now x is a side, you know. We don't know how much it measures, but it's a side. So it's one of the sides that we have to put with another side when we're adding to say it's bigger than the third side. So we're going to put x with 8 this time. So 8 plus x is greater than 10. This also has to be true. So remember, these 3 statements that we're making right now have to be true in order for the triangle to be a viable triangle. So statement A has to be true. 8 plus 10 has to be bigger than x. Statement B also has to be true. 8 plus x has to be bigger than 10. And then statement C has to be true as well. And statement C would just, we have to take the 2 other sides that we have not yet put together. So x and 10. X plus 10 has to also be bigger than 8. So then we go back to the first statement that we made. 8 plus 10 is greater than x. And we simplify that. So 8 plus 10 is 18. So we know that 18 has to be bigger than x. And another way of saying that is that x has to be smaller than 18. So whatever x is at the end of the day, it cannot be bigger than 18. It has to be smaller than 18. And then we go to B. We're going to simplify that as well. Now we have x. We have 8 plus x is greater than 10. We need x to be by itself on one side. We can keep the x on the left side. Get rid of this 8 by bringing it over to the other side. And of course, since this is a positive 8, and we're bringing it to the other side of the greater than sign, we have to change the sign. Alright? So this positive 8 becomes a negative 8 on the other side. So here's what they're doing. They're subtracting 8 from both sides. That's another way of saying what we just said. Subtracting this 8 negates the 8 in front, leaving us with just x. Subtracting 8 on this side, this subtracting 8 has to be done because we did it on the other side, right? So 10 take away 8 is 2. And what this is telling us is that x also has to be bigger than 2. So not only does x need to be smaller than 18, it also has to be bigger than 2. So we've seen inequalities like this before, where you have two conditions that need to be met. The first condition is that x has to be less than 18, because 18 has to be bigger than x, right? The second condition is that x has to be bigger than 2. It's smaller than 18, yes, but it has to be bigger than 2, right? So let's take a look at C. So we had selected the third scenario now is that x plus 10 is greater than 8. So let's simplify x plus 10 is greater than 8. Subtracting 10 on both sides leaves us with x on the left hand side and a negative 2 on the right hand side. Now this turns out to be not a very useful scenario, only because there's no triangle that's going to have a negative length, right? Negative 2 cannot be the length of any side of a triangle that's in the real world. So that doesn't give us any new information, so we can't use it, but that's okay because we have everything that we need already from A and B. So A tells us that x has to be less than 18, and B tells us that x also has to be bigger than 2. See? We can say that differently, you know. We can say that x, we can write it differently anyway. We can write it that x is greater than 2, or 2 is greater than x. 2 is less than x, sorry. 2 is less than x because x is greater than 2. But x at the same time has to be smaller than 18. Note that these two inequalities are saying the same thing, alright? So this is saying x is smaller than 18, this one. X is smaller than 18, but bigger than 2. Whereas this one is saying x is bigger than 2, but smaller than 18. So they're saying the same thing. They're just kind of written differently. And here is the solution that this text provides. So this is written exactly like the one we said, the second one that we did. But, you know, both of them are equivalent. So here. So what we know is that whatever x is, it cannot be bigger than 18, but it also cannot be smaller than 2. Anything in between 2 and 18 will work. You'll have maybe a different looking triangle. Your triangle might end up, you can have a triangle where x is that length. Well, if we call this, if x is 17 here, we can have another triangle that looks like this, where we have an 8 on one side and a 10 on one side, where x is less than 17, maybe x is about 9. Alright? So we have various triangles that will work, but there is no triangle that will work. There's no triangle that will work if x is smaller than 2 or if x is bigger than 18. X has to be bigger than 2 and smaller than 18.